Good morning, you three. Come on in. Happy Friday. How's everyone feeling today? Okay, hands up if you've had breakfast this morning. Everyone, perfect. That means you're definitely going to be ready for the maths lesson today. To start off, I would like everyone to come sit on the floor and find a spot on the mat. Great. So today I'm going to be talking with you guys and discussing and playing about doing some activities on a math phenomenon. Hands on shoulders if anyone knows what a maths phenomenon means. No one? That's all right. A maths phenomenon is something which is impressive, extraordinary, a miracle in the world of maths. Now, knowing the definition, hands on heads if anyone can think of a specific maths phenomenon. Not yet? That's okay, everyone. There are tons of maths phenomenons, but one we're going to focus on today is equiangular spirals, and more specifically, equiangular spirals in nature. An equiangular spiral can be defined as a self-similar spiral curve which often appears in nature. A self-similar object is something that is exactly or approximately similar to a part of itself. This will all make much more sense when I show you guys some examples. First off, to get us moving and thinking, I would like you guys to please put your fingers in your ears and spiral around like that. Awesome. That would be considered an equiangular spiral in nature. It's right on our bodies. Who would have thought? Great. So, everyone up on their feet? I would like you to run around the room. I have stuck up some pictured examples of equiangular spirals in nature. Bring them back when you're finished. Awesome. So what we've got are a few examples here. First off being a lizard's tail. Starts in the middle, spirals around, exactly copying the shape to make a bigger object, to make the tail. Same as the snail, starts from a point, spirals around. Exactly the same as a seashell, that self-similar curve is being seen there. A rose, the rose head, the petals are going around in a spiral to create that rosebud. And on a bigger scale, we have, who knows what this is? Awesome, a Milky Way. If you look closer, you can also see that is in a spiral shape, obviously on a much bigger scale than the animals and fowl we saw. So guys, to extend on this and to make sure you really understand, I've displayed two activities this afternoon that I would like you guys to contribute to. First off, if you could split yourselves, half of you staying on the floor spreading out for an iPad research task, and the second half on the tables to use a new resource. The new resource is called a spirograph. This is to show you guys that if you're starting at the same point with either one of the shapes choices in here, if you spiral that around and around and around, that will create the same object, just bigger. You see? So that equiangular spiral starts from a point and goes around exactly the same. Have a go of those and you'll be able to see what I mean as using that same shape to go around just like all our pitched examples. For the second half of you guys, I would like you to grab the iPads, use probably 2 or 3 per student, and I would like you to research the characteristics of an equiangular spiral. What does the object need to have to be considered an equiangular spiral? For a further extension, if you guys would like to research how this was decided that it was considered a mathematical phenomenon, go off and do that, guys, and we'll discuss our findings in the yarning circle. Perfect. How did everyone enjoy those activities? It was really great to see you all engage and contributing and collaborating with the class. So in this yarning circle, I would like you guys to present the findings you saw in your research task, as well as the spirograph pictures that you made. Furthermore, I would like you guys to go off this weekend and see if you guys can see any equiangular spirals in nature. If you do see some, bring them in or ask your parents to take a photo and email it, and we can discuss our findings next week. It can be an example we've already used or a totally new example. Have a go, guys, and enjoy yourselves. Thanks, everyone.